Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hanis bin Zumaidi, and in this video I will be presenting about my final year project titled Adsorptive Removal of Carbofuran from Aqueous Solution using Granular Activated Carbon under supervision Dr. Zaidi. Background of study. Carbofuran are regularly used to kill insects and other pests as it works effectively. Adsorption process by activated carbon can remove pesticide from the water. For the problem statement, pesticide, or to be more specific, the carbofuran, contaminating the environment substantially due to uncontrolled application which contaminate water sources. Objective of this study: to study the effect of different dosage, initial concentration, contact time, different solution of pH, and different temperature on the removal of carbofuran, and to evaluate the adsorption isotherm, kinetic, and thermodynamic parameters based on the obtained experimental data. Moving on to chapter 2, which is literature review. According to Endopie, wastewater includes all used water in industry and houses, including stormwater and landslide, that should be treated to prevent harm or risk to the human health and environment before being released to the environment. According to Mishra, carbofuran is one of the most toxic broad-spectrum and systemic and methylcarbamate pesticide, which is extensively applied as insecticide, nematicide, and acaricide for agricultural, domestic, and industrial purposes. Activated carbon could be employed in advanced oxidation process for the removal of organic contaminants. As a result, developing environmentally friendly, low-cost, and more effective adsorbent in a hot research area. The use of activated carbon in an adsorption process to remove harmful and dangerous pollutant from wastewater is a common and effective method. Moving on to chapter 3, which is methodology. Activated carbon and carbofuran was being used in this research. The activated carbon is a granular activated carbon, and it is coming from the coconut shell, and the carbofuran, the pure carbofuran, was obtained from the lab. Effect of dosage. The adsorbent dosage were 0.02, 0.04, 0.06 till 1.2 gram were used in this experiment. The initial concentration of carbofuran was 10 mg per liter, and the stirring speed of the shaker was 150, and the temperature is constant, which is 30 degrees Celsius, and it was run for 24 hours. And then the final step is the sample was run at the UVBs. For the effect of different concentration, a feed dosage of 0.08 gram of activated carbon was used, and right initial concentration of 5, 7.5 until 20 mg per liter carbofuran were used, and it is run at the rotary shaker for 24 hours, and the condition is same like the effect of dosage. And lastly, the sample was run at the UVBs. Next is the effect of pH. The pH of the solution will adjust from pH 4 to pH 11 by using 0.1 molarity HCl and 0.1 molarity sodium hydroxide. The amount of adsorbent used was 0.08 gram, and the volume of solution was 100 ml with the initial concentration 10 mg per liter, and the temperature is 30 degrees Celsius with the shaker speed 150 rpm. After that is the effect of temperature. The experiment was carried out at incubator and water bath by using different temperature, which are 20 degrees Celsius, 25 degrees Celsius, and 30 degrees Celsius, with different carbofuran concentration: 5 ppm, 7.5 ppm, 10 ppm, 12.5 ppm, until 70.5 ppm. And the adsorbent dose was 0.08 gram, and the contact time is for about 24 hours. Effect of time. The effect of time on carbofuran removal by activated carbon was studied by using an initial concentration of 10 mg per liter, a stirring speed of 150 rpm, temperature 30 degrees Celsius, and various contact periods of 1 hour till 72 hours. Last part of chapter 3 is about the method of adsorption isotherm, adsorption kinetic, and adsorption thermodynamic. Adsorption isotherm use Langmuir, Freundlich, and Temkin method. Adsorption kinetic use pseudo first order model and pseudo second order model. And the last one is adsorption thermodynamic, and it use thermodynamic equation and Van Hoff plot. Moving on to the next chapter, chapter 4, which is about result and discussion. This is the effect of different dosage results. And here is the bar chart of effect of different adsorbent dosage on adsorption capacity and percentage removal of carbofuran. The removal percentage of carbofuran was found to be 67.69% at 0.02 gram per liter of adsorbent dosage and rose to 88.76% at 0.08 gram per liter of adsorbent dosage. Here is the very peak one. As you can see, it is because of the availability of a greater number of activity centers at higher adsorbent concentration. Chen in the years 2012 reported a similar result when used 1.0 gram per liter or when used 1.0 gram per liter to 1.75 gram per liter of activated carbon, and resulting the percentage removal of carbofuran had increased from 41.04% to 43.56%. Next is the effect of different concentration. Here is the bar graph of effect of different concentration on adsorption capacity and percentage removal of carbofuran. From the bar graph, it shows that the level adsorption of activated carbon on the carbofuran solution had decreased as the initial concentration increased. The initial concentration, 20 mg per liter, recorded the lowest percent removal, which is 65.5%, while 5 mg per liter had the highest percent removal, which is 81.4%. A similar observation was also reported by Chang in the year of 2011. As the initial concentration was raised to 20 mg per liter, activated carbon's loading capacity was raised to 269.52 mg per gram, and the removal percentage was decreased from 59 to 15%. It is because of the increased affinity of the interaction groups on the activated carbon surface speed up carbofuran adsorption. After that is the effect of pH. As illustrated in the bar graph, the quantity of pesticide adsorbed at equilibrium rose from 5.52 to 6.56 mg per gram from 4 to 8 pH. At 9 pH, the adsorption capacity started to drop from 6.56 to 6.1 mg per gram and rose from 10 pH to 11 pH with 6.18 and 6.30 mg per gram. The maximum adsorption capacity was observed at 7 pH and 8 pH. After that is the effect of different temperature. The bar graph indicate that different temperature have impact on the adsorption of activated carbon and adsorption capacity, as the highest percent removal decreased from 71.9% to 19.4%, and the highest adsorption capacity decreased from 13.59 mg per gram to 3.59 mg per gram, with increasing temperature from 20 degrees Celsius to 30 degrees Celsius. The target molecules may be escaping from the solid phase to the bulk phase when the temperature of the solution rises. Next is the effect of different time. From the bar graph, at 1 hour to 2 hours, the percent removal and adsorption capacity were rapid, that from 5.9 to 8.15 mg per gram, and from 47.62% to 65.71% of percent removal. The quick adsorption of carbofuran at the beginning of the contact time is due to the activated carbon positively charged surface being available for adsorption. And then at the time 24 to 72 hours, the bar graph start to be equilibrium. This is due to the activated carbon eventually reach a nearly constant value over prolonged contact of time. Next is adsorption isotherm. Adsorption isotherm were calculated by using three isotherm models Langmuir, Freundlich, and Temkin. In this research followed the Langmuir model as it has the highest correlation coefficient. Table 4.1 shows the monolayer adsorption capabilities based on the Langmuir model, as well as the constant and correlation coefficient for the three adsorptive at 20, 25, and 30 degrees Celsius. The Langmuir model provides the best fit at 30 degrees Celsius since the correlation coefficient or R square values were relatively high, 0.97, confirming that the Langmuir adsorptive was suitable for carbofuran adsorption on activated carbon under the state condition. After that is adsorption kinetic. To obtain kinetic information, adsorption study were carried out at 30 degrees Celsius for various starting carbofuran concentration, starting from 5 to 17.5 mg per liter, and the data collected were applied to pseudo first order and pseudo second order kinetic models. The computed R square values range from 0.885 to 0.985 of the pseudo first order kinetic models, and it is matched well with the experimental data. This result reveals that the pseudo first order model best explains the carbofuran adsorption process on the activated carbon. The last part in chapter 4 is adsorption thermodynamic. Due to the increase in temperature from 20 to 30 degrees Celsius, the adsorption capacity value of activated carbon will decrease from 13.59 to 3.95 mg per gram. The calculated delta H and delta S were 171.93 kJ per mole and 579.13 kJ per mole respectively. The positive value of delta H indicate that the endothermic nature of the adsorption interaction. The positive value of delta S indicate that the affinity of the activated carbon for carbofuran and the elevating randomness at the solid solution interface during the adsorption. The value of delta G for the activated carbon were found to be negative 2.12 and negative 2.78 kJ per mole at 25 till 30 degrees Celsius. It indicates that the carbofuran adsorption by activated carbon grew less favorable at increasing time. Last part is conclusion and recommendation. The adsorptive removal of carbofuran in aqueous solution by granular activated carbon was investigated in this study. The effect of various reaction parameters such as different adsorbate dosage, different carbofuran concentration, different pH, temperature, different contact time and adsorption of carbofuran were examined. Equilibrium was analyzed by Langmuir, Freundlich, and Temkin adsorptive models. The results showed that the Langmuir is the best one, as the Langmuir had a better correlated with the experimental data. Adsorption process is seen to be vital in the wastewater treatment process and more focusing on the removal of the pesticide. Activated carbon was found to be a great adsorbate as it is capable to absorb pesticides such as carbofuran in aqueous solution and can be used widely for the use of agro-industrial waste to remove pesticides that contaminate water. That's all from me. Thank you very much.